Good afternoon, everyone. Thanks for having me here, and thanks, Francesco, for reading this paper. So this is together with Hans van Kipperslaus and Niels Rietveld in Rotterdam, Stephanie van Hinke in Bristol, and Fleur in Statistics Netherlands now. I'm going to talk today about nature-nurture interplay in educational attainment. If I'm saying something weird, forgive me because I'm feeling a bit jet lag. It's like 12 o'clock in the Netherlands, I think, approximately, so it's a bit, yeah. All right, let me move on. So the big question that we keep in the back of our mind while working on this paper is basically, does the environment only complement? So environment and nature and nurture, do they just complement each other, or do they also moderate each other, right? And there's been literature suspecting the relationship, basically that the human capital outcomes are shaped by this complex interplay between nature and nurture. However, the challenges that we have in the literature up until now is that estimating their contribution and interaction is complicated by endogeneity. Right? And why is there endogeneity? For these two reasons. First is that environmental characteristics, they're heritable and they're clustered together. That is for example, higher educated parents have higher educated incomes. We don't know what we want. The second reason is that we talked a lot about today already is the genetic nurture. Is basically genetic variants that reflect environments shaped by parents. And if there is such a reflection, then basically, for example, parental genotypes shape the environment in which children grow up, which may create the spurious association between children's genes and their outcomes. So what do we do in this paper? We study the interaction between genetic endowments and environment in shaping years of education. Both measures are strongly associated with education. There is now a lot of literature on heritability of education, but also GWAS on education and so on. We've covered that. But there is also a big array of birth order literature, which consistently shows that there is a relationship between birth and educational outcomes and other outcomes as well. And we try to get at GWAE interaction here, at the causal GWAE. And how do we do that? So we address endogeneity by using exogenous variation in genetic endowments and family environment within family approach. So genetic variants are random across siblings. That's the according to the Mendel's law and assortment. And also birth order is random within families. And genetic variants are unrelated to birth order within family, which we're also going to explicitly test. So what we find, just to give you a brief preview, is that firstborns on average attain more education. So we manage to replicate the birth order effects in our study. Then polygenic score is a strong predictor of educational attainment. That also holds. Something novel that we add is basically that genetic endowments do not differ systematically across birth order within a family. And that might be because birth order effects are due to mostly environmental influences, which is also shown in other papers by now. And the last and the most important finding is that birth order and genetic endowments interact in shaping educational attainment. That is to say that those with higher polygenic score benefit disproportionately more from being firstborn than those with a lower polygenic score. All right. With this, we contribute to two main streams of the literature. First is the literature on gene-environment interactions, where there are a lot of studies by now with exogenous environments and some new studies with exogenous genetic endowments, and we add to that pool of literature by having exogenous variation in genetic endowments and exogenous variation in the environment. And we also contribute to the birth order effects, which I mentioned finds this differences in educational attainment. And we add to that by showing that there is heterogeneity in the birth order effects by genetic. All right. And there is also literature following up this, showing that birth order effects are intergenerational. So this would imply that any heterogeneity in the birth order effects would also carry over to the following generation. Next, I'm going to cover the empirical frameworks, some notes on the data, a little bit on how we construct the polygenic score, how the data looks like, main results, and conclusions. So let me go to the empirical framework. What we have here is the standard GBI interaction framework, and we look at the years of education, which are converted from the qualifications. We take a polygenic score for years education. I'm gonna tell about the details. We standardize it. In a more recent paper in our team, we show that standardizing also helps addressing the standard censoring in the UKB due to compulsory schooling policies. Then we have dummy for firstborns and otherwise. We have individual controls for month of birth, year of birth, and gender. We control for first principal components of the genetic relatedness matrix to address the ancestry effects. And then family fixed effect. We basically compare the models with and without family fixed effects. And then, yeah, all right. Let me move to the data. So what we use for this study is the UK Biobank, which covers about 10 million people in the UK. I think most of you are familiar with it. I'm going to show what we do with the sampling. Yeah, one remark is that it's not fully representative of the UK population, and we recognize that our results are context specific. For the analysis sample, we do the standard practice in the literature with drop non-Europeans. And then we also clean for missing data on the variables of interest. We end up with about 400,000 individuals. Then we identify siblings and their relatives based on the genetic kinship matrix. And then we keep those families with at least 2 siblings. So we drop twins and single child families. I covered years of education, and we construct birth order basically based on the number of older and younger siblings. Where this is not available, we impute it based on the year of birth and family size in the UKB if all siblings are present. Okay, so this is what we do. Let me first show you how the polygenic score behaves in how we construct the polygenic score. I'm not going to cover how it's constructed. I think there's been enough of that. The only thing I will emphasize is that we conduct our own tailor-made GWAS, where we exclude siblings and their relatives to make sure that this training sample is independent of the holdout sample. And then so this ensures that they're independent, but they're taken from the same context, so there are no other weird GBI going on. And then we correct for the LD structure using LD-BRID, and then the interpretation of the polygenic score in this case would be best linear genetic predictor of the outcome within environmental context of the GWAS. And then it's not purely biological or. All right. So this is how the analysis sample looks like. The average years of education are about 15 years. About 40% of the sample is firstborn. And then polygenic score is standardized. And then the distribution of birth order is as follows, that majority of families have 2 to 3 kids. That's why we have quite a lot of secondborns, and then thirdborns reasonably well, but fourth and fifthborns are fewer. And then Yeah, average family size is about 3, and 40% of the sample is male. All right, what we do first, we test.
Just to clarify, you drop firstborns only. In other words, just have one child family, so they're gone from their sample.
Yeah.
Totally, okay.
Yeah.
What fraction is it?
Oh, I don't have it on the top of my mind, but I can check.
In some countries, it's substantial. I don't know what this data.
Yeah, I think. Yeah, I need to check. But good point. Thank you. Okay, so what we do first, we check how the polygenic score behaves in our data set, and we plot its distribution. As we can see, it's normally distributed, but we also can see that when we plot it against the years of education, it's basically more or less linear. That's important for our specification as well. And then we check more formally what's exactly the predictive power of the polygenic score in our sample. What we do for that, we look between family and within family. We take the regressions with only regular demographic controls, and then we add on the top of that the polygenic score, and we check what's the incremental R-square. Basically follow the regular practice, and we see that between family, the additional predictive power or incremental R-square added by polygenic score is by 5.5%, and then within family that reduces a lot due to this family confounding, which has been also shown in the literature. But it still remains quite predictive and precise and comparable to the other papers. So next, we replicate the birth order effects. Basically, we first plot just residualized years of education without family fixed effects against the birth order, by birth order, or firstborn versus laterborn. We can see that the differences between first and secondborn are more clear, and the third and up are not so precise because there are just not so many in the data. And then when we pull all the later words together, then the differences are more, they're clearer. When we look at this more formally, we can see that firstborns do indeed attain more years of education, both within, between family and within family. And whether we pull them against later words or whether we look at specific birth order, yeah.
So is the outcome standardized? Is like one standardization or it is years of education?
Just years of education. Yeah. Do you think we should better standardize?
No, because it's that's residualized years of education.
Oh, I plotted it just to make it a bit more representative. Yeah. Of
Thanks.
yeah. All right. Yeah. So next, what is important that, as has been already mentioned, to have this independent variation in the genetic variation from the environmental variation, and that's what we test here. Basically, we look at whether there are birth order differences in the polygenic score, and we can see that it looks like, without family controls, that the third born sort of has higher polygenic score. That's what panel A tells us. But in the panel C and panel D, we see that the distributions are quite similar. And then when we test this more formally, we can see that in the between family analysis, there are some imprecise differences by birth order. But once we control for family fixed effect, those birth order differences in the polygenic score, they disappear. So they're independent of each other. And of course, you can question, okay, in the EA polygenic score, there might not be birth order differences. What about other genetic endowments that you can measure? So we test this difference in the polygenic scores from the polygenic score repository. And within family, there are no differences as well. So that pretty much holds for the polygenic scores that we can measure. All right, let me move to G by E. So here I show the estimates of gene-environment interactions. Basically, we can see that from when we move from column 1 to column 2, the estimates of the firstborn and the polygenic score, they do not change much, which again confirms that they're pretty much independent. And then we see an interaction which is sort of borderline significant. In column 3, in column 4 and 5, we show the within family results for this analysis. And there we can see that the interaction is even stronger, and we find the positive interaction. So, however, then we think more about the measurement error in the polygenic score. We know that this measurement error can lead to attenuation bias, and one of the reasons for this attenuation bias is basically that the underlying GWAS is based on a finite sample. And what we do to address that, we basically use this obviously related instrumental variable approach. And if you want to know more about it, Hans and our team has another paper where we compare different approaches for addressing measurement error in the polygenic score. So the basic idea behind this measurement error correction is that we split the GWAS that we were using to construct this polygenic scores. We split it in 2 different independent samples. We ensure that there are no related people in each GWAS subsample. And then we construct 2 independent polygenic scores. The idea is that the measurement error in the 2 polygenic scores is plausibly orthogonal. And then when we put those estimates against what we already have, you can see that indeed the bias in the original estimates is downward. So we can see that the estimates are increasing a little bit, and then they're also more precise between family analysis and within family. Right? Okay. So then we were thinking, like, why would we get this birth order interaction with the polygenic score? And some of the ideas that we have, but we cannot explicitly test them, is that there are complementarities between endowments and investments in human capital. And why investments? So we think of birth order as sort of exogenous random variation in the parental time investments. And why can that be a case? Is basically there is a quality-quantity trade-off in children. With every additional child, it's more expensive to maintain the same quality children with respect to your level of education or health. There is also another strand of literature which says that parents have basically preferences for fairness in investments. That is, they distribute their resources equally over their children, and then natural dilutions, like with every additional child, it would result in dilutions in time investments for later born children. And there are empirical confirmations of that as well. That's basically that parental time investments are indeed a dominant channel in birth order effects, which has been shown by some people. Alternatively, it can be the case that these additional investments are due to firstborn being basically that investments are due to being firstborn are higher because they have higher polygenic score. Okay, we cannot rule it out, but we're thinking that it's less plausible for several reasons. First, there is literature saying that basically when parents are thinking about whether their investment depend on polygenic score or not, the reaction kicks in does not kick in by age 6. And then I think there is a paper also by colleagues here showing that there is no differences in parental investments in the infancy, like up to age of 2 or so. And then we also, when we try to test it with the parental investments that are available in the UKB, we also do not find any differences by polygenic score. For example, for such investments as smoking and breastfeeding. And there is also other literature. Yeah, thank you. By Jason Fletcher and colleagues showing that parents tend to compensate, not complement for genetic differences in children. And the last potential explanation is that other birth order mechanisms, maybe there are some sibling interactions, that older siblings affect the education of younger ones. Unfortunately, we cannot explicitly test it in this data set. All right, we do further a bunch of further sensitivity analysis. For example, specification of birth order, whether it's linear or nonlinear, also linearities and non-linearities in the PGS, and the results are pretty robust with that. We also check the results with alternative PGS, for example, the ones that are meta-analyzed with 23andMe and so on. Results are less precisely estimated because of this additional context of 23andMe, but also we cannot do apply the obviously related instruments to that one. I mentioned that we also check for both order differences in other polygenic scores. We also check what happens if we exclude large families of 3 and above. The results are robust with that. And then we look at some potential confounders. For example, the systematic relationship between birth order and the genetic endowments could arise if parents decide to stop having other children depending on the polygenic score of the previous child. So we add this dummy for being born last. And basically that doesn't affect the estimates that we have for the birth order interaction with the polygenic score. Then we also apply this correction as developed by Matt Keller for controlling for additional interactions, and there the estimates are also robust. Then we check for the sample where it's available for parental age at birth, whether that affects the results or not. And yeah, that I mentioned this about early life parental investments that are available in PV. And then we try to look at the age gap in siblings. And this is a bit harder to do within family because there are not enough siblings of family size 3. So the results there are quite noisy. All right, some of the limitations. So we cannot fully test the mechanisms that I've mentioned, and also polygenic scores are not are a perfect measure of genetic endowments. We recognize that they, as has been talked about already today, they capture only common variants in human genome. Our estimates are likely to be attenuated due to measurement error, and we address part of it by ORB, which addresses only the classical measurement error. So we provide conservative estimates. We cannot address the residual measurement error due to genetic nurture product. That's not addressed by family fixed effects. And then, yeah, there are concerns about external validity because we recognize that the results are specific to the context that we have, so we encourage further replication of our findings. In sum, how much time do we have?
1 and 5.
Oh, okay, great. Yeah, just to summarize, so we're trying to measure this nature-nurture interaction, and then with this, basically these developments in the genetic literature allows us to revisit some fundamental questions. We use exogenous variation in nature and nurture using sibling subsample of the UPB to provide evidence how these two interact, basically refuting these ideas of genetic determinism or environmental determinism. Let's say this is long anticipated finding, yet credible independent sources of variation were not available earlier. Just to reiterate what we find is that firstborns enjoy 0.4 more years of schooling. That's about between 4 and 5 months. No systematic differences in genetic endowments by birth order. We have quantitatively meaningful interaction effect. Basically, those who are born with who have higher polygenic score benefit more from being firstborn. All right. thinking about the big picture, I think there's been quite a few studies showing that the rise in the fraction of later born children was responsible for 20 to 35% of stagnation in college completion among the baby boom cohort. And then when we think that there is basically genetic inequalities and birth order inequalities, and then we also find that the genetic endowments, they amplify the birth order effects. So this would imply, as I mentioned earlier, that this amplified birth order effects, they carry over to the next generations. So that's the big implication of what we find. I think I'll leave you with this. Thank you so much, and looking forward to the comments.
Thank you so much for the invitation. I'm learning a lot. To be honest, like at the end, not too much about genetics until today, and perhaps I don't know, will be obvious by my slides. But let's start from a general point that I think I really like the idea and the research question of the paper. I think it's very very important to understand the interaction between nurture and nature. Um, it's important in a sense that it combines these two literature that seems to be, at least for now, kind of parallel. The child development literature, where that's more what the literature I'm working on, and the genetic literature. In particular, in this paper, the authors are looking at genetic environment endowments as measured by the polygenic score of educational attainments, and the environments measured as a birth order. Okay. So the variation that they're exploiting, as has been said before, is the within family variation that is nice for some reason and has needs some other assumption that perhaps we can discuss toward the end of my discussion in terms of causal identification. So again, very briefly, because I want to jump actually in the comments that I think are more productive. But the main finding that I find interesting is that there is a gradient in terms of the impact of the polygenic score among different children in the same family across the dimension of the order of birth. Okay, and so what the authors find that on average, for those children who were not firstborn, an increase of 1 standard deviation in the polygenic score will increase on average education attainment by 0.57, approximately years of education. But for those who were firstborn, actually is higher. Okay, is 0.77, approximately 0.2 years of education differences across children of the same family. That's the nice part of this. So again, very important question. We like the idea of looking at this nice data that it's rare to find, and a very nice connection that highlight the potential. So hopefully this event will boost again even more the discussion among this literature in thinking about these issues. One comment that would I would say would introduce kind of part of my comments is I think the project could benefit like having a little bit more theory-based analysis of the empirics, and I'll tell you exactly where I'm going now. So I'm going to basically think about an otherwise standard child development model, say a la Cunha, Heckman, and Shenak kind of framework, where there are two equations, just to simplify. There is an outcome equation, which is the educational attainment of children. There are inputs, okay, that are part of the development of the children. One set of inputs are based on the genetic endowment, the primitive of the actual endowment of the genes. There is the nurture aspect, so parental investments, I, and then there is this interaction term. Now you can generalize this for simplicity. I'm thinking about additive separable with an interaction term that is in line with the kind of theory you were thinking. On top of that, there is an investment equation. So this nurture is a behavior that parents choose. In the literature of child development, say parental investment is a function of the information set of the parents. Let's say this is a function of the genetics of children. Okay, so parents respond to the endowment that they observe. Now, this relationship here can be structured in the sense of like derived by resolving a microfounded model, or could be a more, let's say, external or reduced form equation. Okay, but it's a system of equations that connect the outcome to genetics. On the other hand, now we need to define how to map that simple theory in the data. Okay, and the approach, my understanding of the common approach in this literature is thinking about the polygenic score, which is simply a weighted sums of the SNPs over all SNPs, where the betas are estimated independently apart by looking at the association between education and endowments. Okay. But in other words, this association is the association between the endowments, which are the inputs of the production function and the inputs of the behavior with the outcome. Okay, this is something that really caught my attention, because in the literature of child development, that's not what we do usually when we think about mapping theory with data. We trying to measure, or even allowing for measurement error or latent factor, the inputs themselves, looking at the actual inputs, not measuring them directly as an output. Okay, that's one of the difference. And I wonder, I started to think about whether that could have some implication in terms of mapping the theory in the data. Well, one implication, I think, is that if you estimate beta k, okay, which is simply a linear regression model of the genes on the outcome, that would be this, right? So it would be the partial derivative of the average outcome given x. Okay, but that, given my structural model, would be a combination of my understanding of what is called in the literature direct and indirect effects. So it's the direct effect of the gene on the outcome plus the indirect effect of the gene on the outcome through the behavior of parents, which is I. So this is very common actually in the applied micro literature, in the sense of, like, think of these, there is heterogeneity of the average partial effect, and the estimand is estimating an average. The key thing here, though, is that this heterogeneity of the betas across families is driven by nurture. Okay, and so the question is whether, if we think about the contrafactual or the causal impact of nurture, whether those parameters or coefficient of the polygenic score are structural or not with respect to the contrafactual scenario. I don't know the answer. It's something that I would like to put on the table and discuss perhaps even further later on. Again, what is the potential issue here is that these coefficients that are estimated in a sample are themselves potentially a function of the nurture of the family. Said it in English, basically, this is saying that the genes are expressed to the outcome because of the environment that they are exposed to. What would be an alternative or possible solution? Well, again, we need to discuss this, but to alternatively, like implementing a method like in the literature of child development, thinking about, instead of measuring genes through the outcome, is trying to perhaps implementing a factor model, okay, which would instead looking at the covariance and correlation structure between different observed measure of genes at the given time. Okay. Now, of course, here the challenge is that the number of genes are very large, and so there will be some intermediate aspect of selecting what are the measures. One other comment that I think the paper would benefit in a discussion would be related to the endogeneity of the within family variation in gene endowments. Okay, so of course, conditioning on both children, say the case of two children, conditioning on both children being born, okay, the variation in gene endowment is random, but that decision of whether the second child is born is endogenous in respect to the family, so it's the fertility choice. Okay, and so effectively, let's say the fertility choice of a family could be a function of the endowment of the firstborn genes, and it could be a function on top of some unobserved heterogeneity of the firstborn. Now, the good news, as I read the paper, is that the authors rule out by looking at testing in the data, the fact that this fertility choice of the second-born is function of the endowment of the firstborn. So what they say is like they look at the endowment of the two children, and they seem to be orthogonal to each other, which implies that the decision of fertility of the second-born doesn't depend on the endowment of the firstborn, but it could still depend on some other unobserved characteristic of the firstborn. And so my suggestion in the paper would be perhaps in thinking about what are the assumptions that this within family variation is using in exploiting that within family heterogeneity in endowments. And for example, what are the models that could not be estimated, could not be identified by the variation? For example, what if you allow for peer effects among siblings? Would you still be able to use the variation when there is endogenous fertility? And then finally, in this literature where I come from, usually family environment are measured in a different way. For example, in the SNY, we have direct measure of the family of the home environments and home inputs. Here, of course, I can see why this is coming from the data limitation, but the home environment is defined as birth order, which is a measure that I'm not used to, so I was wondering whether there would be a bit more discussion of whether that's a good measure. Alternatively, a possible solution would be, what about implementing an estimator that could allow for a two-sample kind of empirical strategy, like a similar to like a two-sample, two-stage square, or something that combines multiple sources from multiple data. Okay. Thank you.
All right, let's open this up to questions, comments. Sylvia.
Very. So I really like this paper. I think it's a great example of something we've been trying to do. It's doing this GYE where we have like natural experiments and also like the random variation in genetics. One thing that I was curious was in your main table where you estimate the. I don't know if it's possible to put that. Well, yeah. Do we have time to put the main table right?
You have 10 minutes.
Yeah. Do you mind? Yeah. Because I was curious about the interaction, the magnitude of the interaction there. What we can think about, like the between family and exactly. So here's my question. So the firstborn between family and family, there's no difference, right? Which again suggests that there's no immediate variable, right? Family immediate variable in firstborn, right? In this birth order effect. The PGI, as we know, drops by half. Yeah. Which is again consistent with what we know about the PGI between family, right? Direct genetic effects. However, when we look at the interaction, if anything, it increases within family. So that made me question about what these interactions are. Is it really true that by adding fixed effects, we're getting this direct genetic effects on the interaction? You see what I'm saying?
Yeah. One remark in the between family analysis, I don't know if it helps to give a bit more context. We do control for family analysis. It's not perfect family fixed effect control, but with those techniques.
Yeah, but by yeah. Sorry.
Yeah, and then with the this family estimates for interaction, I don't think we claim that it is direct genetic effects. Because family fixed effects, like we recognize they don't perfectly address, but they don't perfectly distinguish the direct genetic effect from the indirect.
So in the interaction, you're not saying that.
Yeah, we're not saying that completely. Like there is a part of, if I'm correct, there is a part of measure of error which still remains there because of this genetic.
But you could do the imputation, right? And then really have the direct and the disentangle, impute parental genotypes.
Yeah, we could do that.
I think it would be interesting to compare this because I think ideally what you want is the GYE with random variations on both sides, right?
Yeah.
Yeah, but very interesting. I don't want to take all time.
Yeah.
Yeah, I like that.
Allison.
So it's a shame Matt Whistle isn't here, but I guess to Francesco's point of expanding the theory, then thinking about just his new paper on diseconomies of scale. So it looks like in the data that you said you can look at the family size, but the number of the amount of time that the first child is just the first child. Maybe something like that.
That's the age gap. Like, whether there is a difference in the age gap or housing score. But that analysis can only be done within family if you have enough families with 3 or more children. So that is like what we can do is only between families, so we are not getting more like
I have a general question, not just the mystical bit paper, it kind of builds on what Francesco was saying earlier. But all of these scores that you're extracting are from some kind of behavior. And this goes back to the point made earlier, and Francesco had a version of this, but I would say I'm thinking of this paper that goes back maybe 17 years or so by Frog, where he was looking at identical twins. So they had identical DNA. And he noticed how the gene expression was fundamentally modified over time. So you actually saw people, even though we knew they were monozygotic twins, that the gene expression, that just looked at the chromosome, had altered. And so by the time they were 50 years old, there was substantial difference. So then the polygenic score, as measured here, would capture some of that experience and modify some of that gene expression. So because you have this vehicle only of a behavior, so I think the whole premise of sort of nature versus nurture is somewhat compromised by this kind of progress study than other studies that show gene expression is playing a powerful role. It's only gene expression you measure. You don't really measure some genetic. Sure, you're not really right. Am I missing something or not? Well, you have these behaviors. And the second question would be: so far we talked mostly about education, but there are a lot of other behaviors. Is this only literature only for education? I mean, seriously, for things like schizophrenia, for health, for all range of earnings and so forth and so
So we'll get to that tomorrow. We have non sessions.
Okay, fine. That's a separate thing. But I still wonder about, the question of whether you can really talk about this nature versus nurture. You're really assuming that this is a purely nature-free environment, nurture-free environment, sorry, that this polygenic score is doing it. And I don't see why that's true. Maybe it is true.
before I comment on that, I see that.
You should answer if you want to answer first.
Yeah, I think my first answer is that we do not capture, we do not try to observe or say anything about the measure this genetic variation which shows that there is an educational advantage of both between family which is also a result of random lottery that you get. But I agree, we do not observe or try to observe the genetic changes. The only thing that might help here is in the report is when we do control for year. Here, of course, we didn't really make a dress, but for some age difference. Maybe that for partial address for parental age in some situations. But I know it's not perfect kind of control or
I'm just wondering how imperfect it is.
Yeah.
There's a state.
Dan,
So I agree. It's a fundamental point that Francesco raised that I think Jim is echoing, that the polygenic score is not purely a measure of genetic endowment the way economists would think about that in a theory, because it incorporates the effects of environmental reactions to genotype that are, captured when you do the GWAS, you're just getting the reduced form association between the genotype and and educational attainment.
But also the genotype itself throughout the life cycle. That was the Frage point.
Well,
So
the
it's not that genotype is stable either. People think it's there, but it's not. I mean, at least the expression, those chromosomal expressions are changing. That's what I'm saying. That to me is my fundamental point. I don't know how important it is for this literature.
Well, the measure of the polygenic score is based on the genotype at conception, which doesn't is predetermined relative to any kind of changes in gene expression over the life cycle.
Yeah, but the measurement, like if the mother smokes in utero, I mean, that can be something just directly on you. They can also do something indirectly through epigenetics. They have it genetically, and you're capturing both of those things. Is that the point?
Yeah, that's right. It would modify the behavior
So
down
even
the
though,
road.
so the relationship.
How the initial
measure
score
is gonna
is changed.
include how the environment affected gene expression.
But I think there's two things to separate though. The thing that's on the right hand side of the gene is observable the genotype. That is not changing. Right? That is not that. And now it is also then true though that the
But
relationship.
those betas are gonna.
Yeah, the betas.
Yeah, that's absolutely true. Absolutely. Yeah.
And the score is changing. I didn't say the initial genes were changing.
Yeah.
But the expression was changing and the data is therefore will change.
But not only the expression, but anything that is environmental that is on this GWAS, right? Epigenetics is just one of these factors that are.
No, I think what
Right.
Francesca was saying was right. The other, what weird flowers don't grow in deserts.
So the comment I wanted to make is that you may want to look at the appendix to there's a Terskaya and Sanz de Galdiano paper. They have some discussion of a model where they incorporate, along the lines of what Francesca was suggesting, they incorporate parental investments and other kinds of social and responses to genotype and discuss under what kinds of assumptions can you interpret the polygenic score as a genetic endowment, and what would happen if those assumptions are violated.
That's gonna take some pretty strong assumptions.
It's going to take strong assumptions. Yeah, absolutely. But it's helpful to see what those assumptions are and spell them out.
Those, give an outline, give a roadmap, and kind of assumptions you get him to make. You could use much more complex technologies too, so.
Laura.
Well, yeah, just piggybacking off of that, I think a lot of us are getting increasingly uncomfortable with calling it a genetic endowment. It's not. It's a polygenic score, which is the average effect across all cellular states, all environments that are in. And so I don't say genetic endowment. In my papers, I say polygenic index. And I think that's, you have to be clear with what it is.
But then why is this index interesting?
Oh,
It
so
was interesting initially because you thought we were gonna isolate genetics. Now you're not. So what is it it's isolating? It's an artifact. So why not just put the other things to measure?
Yeah, still on the same line. So in a sense, this is a reduced form model. At the end, we observe some kind of correlation between the PGS and an outcome, which is interesting per se. We have learned something looking at this. The problem is we don't know the mechanism. Like for instance, this positive coefficient here of the interaction. The definition that comes to mind naturally to an economist is A, parents invest more in their firstborn, say because they have more time. And B, there is a complementarity between the parental investment and the PGS in the sense that the same investment is more beneficial for kids who have a high PGS, right? Now, of course, in this regression, there is no way you can compare this explanation with anything else.
Yeah.
But it's simply if the investment, there was this notion that the beta is not constant, the coefficient is not constant. Now, in particular, if it's related to investment, then any variable about the parents that might influence the cost of the investment should be relevant. So at the very least, if I don't know your data, right? But if you have something in your data that could be correlated with the cost of investment for the parents, then you should interact this with the firstborn times PGS, which is exactly this notion that that Because if different parents have different cost of investment, then you would expect that the beta will be different. If you know, if the channel is this kind of indirect channel through the investment, anything that has an independent impact on investment should matter. So at least you could test whether it's the case or not.
No, that's a good point. Cross-checking debate, I'm not sure, because there is also not much with the investment return. That's why we moved the storyline with the investments to potential explanations, not like, because our main storyline was more with the investment and actually workload and approximately, but yeah.
Following up on the question I asked you when presenting, how did the firstborn children, the only, single children, compare to these firstborn children in terms of outcomes? Is that another measure of investment? I mean, literally, that one is just, you're all alone, there's no investment, so that's a pure effect. And the other is like, here's with the affected investment. So can you do that, can you isolate it this way? I don't, how different are they?
I
Solitary firstborns versus these.
Yeah.
We're over time. I'm reading faces. Sorry to say. I think, you know, we'll have a big discussion time when it comes to the econometric session tomorrow. Especially we have, unfortunately, Matt Wiswall will not be able to join us because he's ill. So we'll probably have more time for the discussion session. I think this point about is the terminology genetic endowment problematic or meaningful, or what does it capture relative to what we can measure, is an important conversation to have. And I think if I rather than delaying you getting to beer or dinner or whatever now, I think that might be something that would be interesting to talk about in the econometric session tomorrow. So, and I have some thoughts on that. So okay. Thanks everybody. I think this was a good first day.